Okay, good afternoon, Form 4. Form 4 student. This is a second group. It's Wednesday today. Okay, I hope everybody doing fine in your school. Okay, catch up all the lesson in your school and can able to finish all your homework. Huh? So remember to stay strong. Work hard. Okay, every day go back to school to learn. Whatever you can, you learn. The more you learn in school, the better. Okay. But remember, you have to take good care of yourself. Always protect yourself when you go back to school. Because our school is a public place. So we have to, everybody also same at school, a public place. So we have to protect ourselves. So the minimum thing we can do is by wearing a face mask. Okay. So in fact, the government is, I think, they are going to implement soon, make it compulsory for everybody to wear face masks in public place. Example, school. School is considered public place already, so it's compulsory to wear a mask later on. Maybe the government will announce, they already decided to implement it, make it compulsory. Because this COVID-19 it seems like not soft, it's getting more serious now, actually. From single digit right now, it back to consistently that become double digit now. Every day now. And more cluster file being identified. More and more cluster now. No, this is not a good news, Not only in Malaysia, in Singapore also the same. In Hong Kong also the same. It seems like the second, third wave is coming, So everybody have to be extra careful. You can avoid, you don't go public place, don't go shopping center, don't go, if possible. Okay, so take good care of yourself. Everybody wear a face mask, especially go to school. I know many students they don't like to wear face mask in school. Okay, I don't know what your school. In my school, I observe my students, quite a number of them, they don't wear. They don't want to wear. They say not compulsory. Yeah, because the Ministry of Education say not compulsory, but the Ministry of Health say have to make it compulsory already. Okay, okay, come back to our lesson. Our last lesson, we stopped at this refraction. Okay, I share with you the paper now. You see what you have learned last week. Okay. One moment now. This one. Refractions of wave. Correct not? Last lesson we started this halfway through. Correct not? Okay. By the way, anyone can tell me, what is refraction? Actually, what is refraction? Anyone can explain to me or not? Try your best. What is the meaning of refraction? What is refraction now? Hashini, what is refraction? Hashini, are you
Wave
there?
moves from
Yes. What is Come again.
wave occurs when the wave moves from one medium to another, which causes to travel at different speed.
Yes, correct. Refraction must involve wave moving from one medium to another medium with different density. When moving through different density, right, the speed will change. Once the speed will change, right, so the wave will change direction. So changing direction. So the keyword is what? No, changing direction. The wave changing direction, as then we call it refraction. Refract means change direction. The wave changes direction. Okay. The reason is because change in the speed happen. No, once a change in the speed, right, it will change direction. Okay, and that one is a basic knowledge of refraction. Everybody must remember. Okay, I want to ask one more question. What are the things will change during refraction? What are the things will change during refraction? Chan Yuan Yi. Chan Yuan Yi, can you hear me or not? Chan Yuan Yi, not there already. Okay. Cannot talk, I type you here. Let me see what you type, Chan Yuan Yi, can you answer or not? What are the things will change after refraction? After refraction, what will change that? Can answer or not, Chan Yuan Yi? No, he's on the screen. You see the screen? What are the things will change? What are the things not change also there? Okay. So what are the things? Okay, I see what you type, Direction. You type direction, Direction change or not change, Chan Yuan Yi? Okay lah, never mind lah, You can see here lah. The frequency when refraction happen, right? Frequency does not change. Frequency never change at all. But the wavelength, the speed, the directions are changed. Understand? Three things will change, wavelength, lambda, the speed, and the direction, of course, will change, right? The only thing that not change is the frequency. Frequency not easy to change, okay? So this one basic thing I don't want to ask you already. You have also designed all this diagram, right? Last lesson, you have drawn all this diagram to show the refractions of water wave, correct not? Okay. Now, I believe we have to look into the experiment now. Okay. Last week, you have learned how to draw the diagram to show the refraction, right? Okay. Now, actually, the next step is you must carry out the experiment, to show all these things, to show this one, all this. So, how to do the experiment? You see the diagram. I use the diagram to explain to you first. Everybody listen. Okay. To show refractions of water wave, right, you must use a Ripple tank. This is a Ripple tank. So water, you keep water here, okay? Ripple tank, you pour a little bit water here and make sure the water here has uniform depth. The depth must be uniform, throughout. Then you put a piece of this perspex plate inside the water to make this part water become shallower. You see this diagram, right? Water here is deep water. Then you put this one piece, two pieces, three, four pieces of perspex, right? The plastic. You put it inside the water. The purpose is to make the water shallower. So here, the water becomes shallow. Here, the water is deep. Understand? So meaning that in a Ripple tank, here, this part, the water are deep. Then only this part, the water are shallow. So our aim is to look at the wavelength here, what happened to the water wave when go through the shallow region, this part. Yeah, okay. But of course, we don't see here, we have to see at the bottom. Look at the bottom, the white paper there, correct not? So in order to see clearly the line of the wave, right, you must see through a stroboscope. So this is a stroboscope. Stroboscope is a small machine, keep turning. While this thing is turning, right, then your eyes is here, so you just see through, then see. Okay, what function of the stroboscope? Remember or not, you all? What is the purpose of looking through this stroboscope? Juling, why we need a stroboscope here?
Freeze the wave.
Yes, to freeze the wave, meaning that something like to make the wave here stop moving so that you can see them, right? How to freeze is like this now. When rotation frequency, same as the frequency of the water, both of them having same frequency, right? So the water will appear to stop moving, like freeze already. Okay, then easily for you to see the line. So this is the function of the stroboscope. Okay, In this experiment, the title you see is what? Title of the experiment is to see the relation between the depth of the water and the wavelength. We already know the answer. When the water is deep, right, the deeper the water, the wavelength lambda getting bigger, correct not? Now you see here, you see, this diagram. When here is deep water, you see the lambda is big, the wavelength big. When going to shallow region, you see the lambda, the wavelength become very small. So the relation is what? The deeper the water, the bigger the wavelength lambda. Okay, that answer you know already. But we need to prove it in this experiment. Okay, to see the relation between the depth and the wavelength. Okay, hypothesis, highlight. The depth of water increases, the wavelength also increase. When the water gets deeper, the wavelength getting bigger. Aim to investigate the relationship between the depth and the wavelength. Okay, this one okay now, Okay, variable. Okay, make sure you understand Manipulated variable is the depth of water, means you control the depth of the water. And responding variable, okay. How to control the depth of the water? How to change the depth of the water? Okay, do like this. Okay, look at here now. Okay, at first, you only put one piece of perspective, one piece today. Put one piece inside here. When you put one piece, so the depth is deeper. The water here is deeper when you put one piece only. Okay, maybe we'll start with, we see the result. Start with 10 cm, 10 cm. Then shallower become 8, and so on. Okay, first you start with 10 cm, you do like this. Okay, you put one piece of perspective plate, use a ruler to measure the depth of the water here is 10 cm. Let's say here 10 cm. When you put one piece, so the depth is 1 cm. 10 cm, sorry. 10 cm of water. Then you on the motor. So the motor will vibrate, touching the water to produce a water wave, right? So the water wave will go over here. Then, but you don't see here, you measure the wavelength here. You measure the wavelength on this shallower region. Okay, like this, see your result. You start with 10 cm. You put one piece perspective inside the water. You measure the depth, let's say it's 10 cm water. Then you see, you measure the wavelength, lambda. Measure, Then after that, the depth decreases to 8 cm. How to make it 8 cm? Like this, you put two pieces now. Two pieces of perspective. Just now you put one piece, it was 10 cm, the water. Now you put one more. Now, two pieces of perspective. So the depth now become 8, shallower already. Right? I repeat now. Just now when you put one piece only, so you measure the depth of water, it was 10 cm. Now finish 10 cm already. You want to make it shallower. So you add one more piece, so become two pieces. Then you measure the depth of water is 8 cm now. 8 cm. Then you on the motor, let the water wave go over here. You see the lambda here. So you measure on the white paper. Okay, you see. Okay. Just now 10 cm, what is the wavelength? You measure. After that, 8 cm, shallower, right? See what happened to the lambda. Then next, 6 cm. 6 cm means you put one more piece. Just now 1, 2, now you put 3. 3 pieces. So the water left 6 cm only. The depth of the water is 6 cm. Shallower, getting shallower, 6 cm. So you repeat the same thing. You understand the experiment or not? Okay, when you look at the result, means I see 10 cm means you put one piece of perspective plate inside the water. You put one piece, so it's deeper, right? Then you put two pieces, become 8 cm only. 3 pieces become 6 cm, getting shallower. The more glass you put inside the water, right? The water becomes shallower. Understand or not? Juling, understand or not? Juling, Hashini, understand or not?
Yes, sir.
Understand? Okay. So the experiment is like that. We do like that. Okay, come, go through here first. So manipulated variable, right? You control the depth. How? Please jot down by adding glasses inside the water. Adding now. First, you put one piece. After that, you put two pieces, three pieces, and so on. By adding the plus glasses or perspective inside the water. Okay? Then you control the depth of the water. Responding variable is a wavelength. You see what happened to the wavelength, the lambda. And fixed variable is very important, no? The frequency must stay constant. But how to ensure frequency stay constant? I want to ask you all, see whether you all got common sense to answer or not. How to ensure the frequency stay constant? How in this experiment? By just saying only cannot one, you must know how to do it. How to guarantee the frequency is fixed? How? How you do it? Susin, how you do it now? How you can ensure the frequency stay constant? Susin. Susin,
Not
are you
sure, sir. Not
not
sure.
sure? Okay, never mind. Okay, Shima, are you there? Shima,
Yes, sir.
Shima, boy must know
Uh,
one. How to ensure the frequency stay constant?
the power supply must be same.
Power supply. Partially correct lah, but not fully correct yet. No. Okay, the right answer should be okay, maybe I ask one more last student. Someone answer here. See, Juling say control the speed of the vibrating bar. Yes, Juling, you are right. Control the speed of the motor of the vibrating bar. You control lah. So meaning that when you don't change the speed of the motor, it means the frequency will not change. The motor speed can be changed one, you can make it faster, make it slower, right? So when you don't change the speed of the motor or the vibrating bar, right, the frequency will remain the same. So my question is, how to ensure the frequency same? So the answer is, the speed of the motor remains the same. You don't change the speed of the motor. The motor, the speed can change. You don't change the speed of the motor. When you don't change the speed of the motor, right, the frequency remain constant now. Okay, understand now? All right. Susin, understand or not?
Yeah, understand, sir.
Okay, good. Okay, now next. List of apparatus. So you did the reaper tank. Reaper tank is the whole thing now. Lamp up here. You must have the lamp, Lamp now, the light go through the water, then you see the shadow on the white paper here, correct not? Without the lamp, you cannot see anything here. No, you must have the lamp on top. Motor, wooden bar, power supply, white paper, all this here must have what white paper, protractor. Okay, we don't need to measure any angle, so no need protractor, cancel it. We don't need a protector here. Reflector also we don't need, okay, cancel. These two we don't need. Perspective plate, yes, you need to put one piece, two pieces, put inside the water. Okay. Meter rule, to measure the lambda, you need the ruler lah, and a stroboscope. Okay. Okay. All right. Procedure, I don't explain already. You are going what? Read yourself lah. I only want to explain to you the table. Table can show you how to do the experiment already. So you start with controlling the water depth 10 cm. Okay, you put one piece of perspective, so you measure the depth is 10 cm. Then you see what is the wavelength. After that, make the water shallower by adding more perspective inside the water. When you add more, it becomes shallower. So 10, 8, 6, 4, and 2. Okay, I just want to ask you all now. You can see here, when the depth decreases, you see here decreasing, right? Here is deep, getting shallow, shallower, right? Okay, what happened to the wavelength then? What is our expectation? When the depth decreasing, what happened to the wavelength lambda? Justin, are you there?
Yes, teacher.
Justin, when the depth decreasing, what happened to the wavelength? What
Increases.
result you expect here?
Increases.
Yes?
Increases.
Yes, also decreases, okay? Same, So meaning that when the water getting shallower, the lambda wavelength produced also becomes smaller. Jot it down, When water getting shallower, the lambda also becomes smaller. So it's very important you all know, jot it down, So you must expect the answer here becomes smaller, when here's getting smaller, here's getting smaller. Okay, what about the graph? The graph, how to plot the graph? Responding variable is a wavelength lambda. Manipulated variable is the depth. So what about the graph? What shape? What is the shape of the graph then? When depth decreases, wavelength decreases also. Is what relationship like that? What relationship is that? Convention? Can you tell me, the graph is how one? How's the graph? Convention, are you there now? Convention, not there. Okay. Ngu Yu Tong. Yu Tong, Yu Tong, are you there?
Yes, sir.
Can you tell me, the graph, the graph is a line go up or you go down, can you tell me?
Go down.
Go down, Okay, you don't, don't answer first, you listen, When depth decreases, lambda wavelength also decreases. So this is what kind of relation? When this one getting smaller, here also getting smaller, like that, what relation? Is inversely or directly? This kind of relation. This one getting small, this one also follow getting small. So what relation? You don't?
Directly proportional.
Yes, correct. It's directly proportional because same pattern, This one getting smaller. Here also getting smaller. So the pattern same. Same pattern means directly proportional. So when it is directly proportional, the graph must be a straight line graph passes through origin. Okay, straight line, it's a straight line. Okay, directly proportional. No, it's the same, you see, when the depth getting bigger, deeper, right? The lambda should be bigger, correct? Right? Directly proportional, When the water get deeper, here is deeper, right? The lambda must get bigger. Okay, so it's directly proportional graph. Okay, please jot down, Okay, when you see like this, when the pattern same, this one getting smaller, this one getting smaller, same pattern, that one is directly proportional. Okay. If the ballet one, then it's inversely, but this one getting small, this one getting bigger, then the ballet, that one is inversely proportional, okay? But this one same pattern, getting smaller, here also getting smaller, so it's directly. Directly proportional means it must be a straight line graph go up one, okay? Hey, understand or not, everyone? Susin, understand?
Yeah, understand, sir.
Understand, Okay, what about others? The rest are all no sound one. Convention. Are you there, Convention? Lao Quan Xuan, are you there? Lao Quan Xuan, understand? Lao Lao Quan Xuan, understand or not? I see you on the mic already. Why no sound, Lao? Do you understand, Lao?
Understand.
Can, okay. Thank you. Very, very soft now. You're too shy to talk. Put your microphone near to your mouth now, huh? Okay. Don't be too shy lah. Okay. So the experiment finished already, huh? Okay, now actually this one only lah is the same lah. Just have a look lah, huh? Actually, I already explained to you just now lah. This one, okay? Now, another result is like that, no? Depth 60, this one millimeter lah, 60, 50 getting smaller, right? Then you notice that the lambda also getting smaller. Correct? This one you can jot down as example lah. Okay. When the depth side is 60 millimeter, 50, 40, 30, 20, 10, getting smaller, then lambda also becomes smaller, 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 getting smaller lah. So directly proportional graph, okay? Yeah. Done or not? Everything, everyone. Durga Devi. Understand or not? Durga?
Yes.
Justin, understand now? Justin put
Yes, sir.
thumb up. Understand now? Okay, come. And now we have to move in one section which is very, very important one. This one actually came out in the SPM many times already. In essay question, they ask you to explain. Okay. I want you to look at this diagram first. Don't look at the note first. Okay, just the diagram only. Okay, this is the seaside. This is a beach, the shore, the seaside, right? This one is the seawater. So you notice here now, when far from the shore, right? The shore is here. The shore divided into cape. The one go out, right? Is called cape. One bend in one is called bay. Cape and bay, remember no? Cape go out one. Bay curve in one. So cape and bay, Okay, when far from the shore, right? You see the water wave far. Here is far, very far from the shore. When this is far, you notice the water wave, the uniform. Straight line and then uniform. Straight line, you see, uniform one. But when go near to the shore, you notice that the water wave start bend, it will bend, and finally it will follow the shape of the shore. Okay, you see or not? The question is in that year they ask student to explain why when this water wave will take up the shape of the shore when approaching to the beach, why it will follow the shape? Very big question, Why this water wave will take up the shape of the shore? Guarantee one, when the shore, the shape is like that, the water wave will become like that. It will follow one. Why? Okay, this one definitely related to reflection because you study refraction here, so it must be refraction. Refraction cause the wave to change direction, Change direction means it will bend. Okay, it will bend and then follow the shape law. Okay, come, let me explain to you why before you look at the note. Why here the water wave are all straight line and uniform? Because when far from the shore here the water here has uniform depth. Here no problem here. When far from the beach, right, the depth of the water are uniform depth. When uniform depth means the wave will be uniform straight line, the water wave straight line one because uniform depth here. Okay, the water will become shallower, when go near to the shore, right? So the depth decreasing. Here is deep, still deep, then becomes shallower already. When go near to the cape, it becomes shallow. Here also same, Here water is deep, here is still deep, but go near here, it becomes shallow. So one reason is because why taking up the shape length is because the depth of the water decreasing when approaching to the shore, right? So the depth decreasing, one. Depth decreasing is not enough, The speed also decreasing because you know that in deep water it go faster. When go to shallow water, it becomes slower. You see, slow. So the speed changing, the speed decreasing, the depth decreasing. These two is enough already. It will cause refraction. Okay, you remember now. From deep water go to shallow water, right? The wave will refract towards the normal, bend towards the normal. Okay, the bending of this wave, right, bending towards the normal will cause the water to change shape, right? Okay, same thing happened here, but here now, because of this distance is longer. When go to the bay, right, the distance is longer. Longer means the depth of water decreasing slower. Here, the depth decreases very fast. Here, deep suddenly becomes shallow. Because nearer already, Here is deep, here is deep, here is still deep, Here is still deep, then here only start to become shallower. So meaning that the depth here decreases slower. Depth here decreases faster. So it will cause the change in the shape become different. It will bend. Okay? Bend and then take up the shape of the beach. Okay? The reason now. So there are few reasons here. You see, you must say the depth decreases, the speed decreases. After that, you say water wave refracted towards the normal, right? There are few points now. Then it will cause the wave start to bend, change shape. Okay? Okay, come, we go through the paper now. This one important. When the water wave propagated from the sea to the beach, from here to here, the water wave follow the shape of the beach. This is a question. The water wave follow the shape of the beach. Then the next ask you why. The reason is, it is because water wave propagate from deep water. Here is deep water, to shallow water. From deep water to shallow, from deep to shallow, right? The speed and one more, the wavelength. You see the wavelength here, wavelength big, and then the wavelength lambda here getting smaller. In shallow region, the lambda becomes small, right? The speed, the lambda wavelength decrease as the wave approach the beach, right? So depth decreases, speed decreases, and one more is the wavelength lambda also decreases, okay? Speed, wavelength decreases, and then it becomes shallower, right? Not. Hence, the water is refracted towards the normal. These are the key points. You must answer this. Okay? Refracted towards the normal. That's why the water will become bend. It will take up the shape. The main reason is here, right? Okay. That is another thing. Okay. Taking up the shape, I want done already. Now I want to talk another thing. You want to listen more? Okay. Another thing is near the cape and near the bay, which area is suitable for swimming or fishing? Near the cape or near the bay? Your use of common sense. Justin, how do you think? Normally, you want to swim, want to do fishing, you do near the cape or you do near the bay?
Cape.
Cape. Justin said cape. Susin said cape. Also cape. Chiu-Ling, what do you say, Chiu-Ling? Bay. This one, Susin said bay. Just now cape, now bay, bay. Not bay, no. Double bay, bay, bay. Yes, the answer is bay, Okay, come listen. Why then? Because you look at this diagram. Near the cape, you see this arrow arrow show the energy of the wave, because bending now, because all the wave energy are focused to the cape, So meaning that now the water near the cape actually are having a lot of energy. When the water having energy means the water current is very strong. The wave is very high. And then the water energy high now. So this water basically are turning one, They are turning one. The water is dangerous. So you don't swim, don't do fishing here. Cape cannot one is too dangerous. The water is turning. That one make it so dangerous. Okay. Why turning the water? Because energy is very high. All the energy focus to the cape. Focus here. Okay. All these are because of refraction. Refraction causes the energy focus at the cape. So it makes the cape too dangerous to do anything. The current is strong, the wave is high, and the water is turning. So basically, nothing can be done here. Okay, compared to the bay, right? You see the arrow? Bay, okay. The energy spread wider. You see, the energy spread out. Because the direction of bend is different, Okay, so it will spread out to a wider area. So make this part the water having very little energy. When the water having very little energy means that the water's very quiet. So the water basically are stationary. So it's very safe. You can swim, you can do fishing, everything here. So it's safer to do here. Why? Energy is less because the energy spread to a wider area. So less energy. Okay. All right. Now you see here the explanation is here. The water in the bay stationary or calm. The water is calm here. Yeah. Compared to the water at the cape. Okay, here water is stationary, very calm. Here, no. This is because depth of water varies slowly across the area of the bay. Here, just like I told you, right? The depth decreases slowly. Here, the depth decreases faster, right? Okay. Depth of water varies slowly across the area, and the energy of water spread to a wider area compared to the region near the cape. So the amplitude means the height of the wave. The amplitude of water wave near the bay is low. Hence, water at the bay is comparatively still. The water here still stationary one, very quiet. Okay, so basically all the water activities must be only carried out near the bay only. Nothing you can do on near the cape. Too dangerous. Okay. Okay. Now I give you a little bit time. I want you to read through the whole thing, understand it, okay, memorize it, okay. Later on, I will ask you question. Okay, you read it now. Okay, start now. 2 minutes or now. Okay, done or not? Okay lah, time's up lah, huh? Okay, you all don't need to worry so much. If you don't know, you just say don't know lah, huh? Don't worry, huh? Okay, all right. First, let me see, I want to call Hashini. Where are you? Hashini, are you there?
Yes, sir.
You're always the first one. You know I'm going to call you one, huh? Hashini. Hashini, can you tell me now, actually, why the water wave you will take up the shape of the pitch when they approach to the pitch? Why you will take up the shape of the pitch? What is the reason? Roughly, you tell me now. What is the reason?
Because the wave moved from deep water to shallow water.
Yes, one reason is water moving from deep to shallow. Any other reason?
The speed and the wavelength also decrease as
Yes,
they approach the beach.
correct. Very good answer. Okay, thank you very much, Hashini. So she already mentioned three things, One, she say the depth of water decreasing. Second, she say the speed decreasing. Then another one, she say the lambda wavelength decreasing. And when approaching to the beach, right? Then all these things decrease, it will cause something to happen. What I mean by something to happen, the something is what here? Juling, something here is means what? I say something will happen. What is that? What is the something here? Juling.
Teacher can repeat your question.
Okay, can. My question is, I say just now we say the depth decreasing, speed decreasing, wavelength decreasing, right? All these things will lead to something to happen to the water. Something to happen here is what? This something is what, Juling?
The water will keep turning or what? Or the energy will be focused.
No, this is not what I want. Justin, what about you? Justin, you know or not? The something happened. The something is what?
Refraction.
Yes, correct. Refracted. So the water will be refracted lah. Juling, understand lah? Okay, meaning that when the depth decreasing, speed decreases, wavelength decreases, right? All this will cause the water to have refraction. Refract towards the normal. So refraction happen now. So once refraction happen, right? So the wave will change direction, it will bend, When the water bend, it will take up the shape of the beach, correct not? And some more, when it bend, right, it will also cause in the cape the energy focus to the cape. Whereas near the bed, the energy will be spread out to a wider area. All these are because of the water changes direction, because reflection. Understand? Yeah. Okay, next question. Next question is Chua Wen, are you there? Chua Wen. Are you there, Chua Wen? Chorwen or this one all stay behind the scene one. Don't want to say anything. Okay, Chorwen, you type. Chorwen say yes. Chorwen, my question is like this. Why it is not safe to have water activity near the cape? Why? Why not safe to have water activity near the cape? Chua? Why? You cannot talk, never mind, you type. Okay, you type it up. Why not safe to have activity near the cape? Okay, I see your answer. You type already, right? Okay, you say the energy too strong. Yes, correct. The energy too strong because the energy focus to the cape. The energy of water energy too strong, right? So it will cause the water very the current, the water current is very strong. So sometimes the water will turn, so it's too dangerous. Okay, Next question. Why the water near the bay stays stationary? Why? In the water near this bay, usually the waters are calm and stationary. Why? You don't? Why? You don't? Why the water near? Okay, you don't, you answer.
Because the depth decreasing so slowly.
The depth decreases slowly. Well, one more important reason, you don't. Why here the water is stationary? Another more important reason is what?
The energy spread out.
The energy spread out wider area. Not focus like here, focus, just spread out. So the energy less lah. Okay, thank you, you don't. Okay lah, so this part okay already. This part you better go and read through again, go and memorize the whole thing, This is very important one, I tell you. This one, Okay. Next, reflection of light. This one light, I can go very fast. Light, very simple. Light also can be refract, right? Okay, Okay, I want to use a diagram to explain to you first, then only come back here. Okay, you see here. I only want you to focus on these two diagrams. Once you understand these two diagrams, you understand everything already. Okay, come look at the diagram. Okay, this one is light, right? Okay, light, you see, here is A. A is less dense. Here is water. Water is denser. Okay, so when the light moving from less dense to denser, right? So it will, the speed decreases, in the A, the A move faster, the light move faster. When go into water, it moves slower. So the speed decreases, here fast, here slow. This side it will bend towards the normal. Remember, from less dense to denser, right? It reflects towards the normal. The normal is here. This is a normal. Bend towards normal, so it bend to the left side, bend towards normal, reflect towards normal. You have to remember, from less dense to denser of the light, right? Light reflected towards the normal. Okay. Another thing you need to notice, the speed of the light decreases when moved into the denser medium. Fast, they slow down. Okay. This is what happened now. Okay. Another diagram. This is the other way around. This one is glass. Here is A. So the light moving from the glass go out to the A. From denser to less dense. This one denser. The glass is denser. A is less dense. Okay, now from denser to less dense, right, is refracted away from the normal. This is a normal. Away from normal. So it bend away from the normal. You see, not away from the normal. Okay, away from normal. Refract away from normal. So can you remember or not? Less than to denser towards normal. Denser to less than, bend away from normal. That you have to remember. You don't remember now, nobody can help you. Okay. You have to help yourself. No, remember it. Okay. Okay. Another one you need to notice, when move from tensor to less than, it get faster. The speed increases. In the less than medium, the light go faster one. Okay. So these are the few things you need to know lah. Now refractions of light is like that only, nothing much. Okay. Yeah. Can understand? Okay, you copy whatever you want lah. On near the diagram. Okay, later on only we see the explanation. Okay, come copy now. Yeah. Okay, now the theory we look very fast here. Refractions of light is a phenomenon where the direction and the speed change. Remember now, refraction involving change in direction and change in the speed. Okay. When it crosses the boundary between two mediums with different densities, you know lah, from air to water, from glass go out to air. Okay. So the definition of refraction you must know, direction and the speed of the light change when it crosses the boundary between two material with different densities. Understand? When a light travels from less than to denser, like the first diagram, less than to denser, right? Bend towards a normal, refract towards a normal. After entering the denser medium, the speed decreases. Okay, this one you know already. Okay, next one. Next one, same lah. When the light travel from tensor to less than, here tensor to less than, the ray bend away from the normal, refracted away from the normal. After entering the less than medium here, less than medium is here, so it go faster. The speed increases. Okay, understand? So refraction of light, very simple. Okay, the experiment I will discuss very, very fast. Same experiment like water wave just now. To see the relationship between the angle, this one a bit different, sorry, angle incident and the angle of refraction. Okay. What is angle incident and what is angle refraction? So you see like this, Okay, look at this diagram here. Only this one, this diagram, Okay. To have refractions of light, you want the light to refract, so you must allow the light travel from A, go to a piece of glass. From less than, go to denser, so it will bend, right now it will refract. So the experiment using like this using a piece of glass, this somebody take one piece of glass. So you have light come from the box. Inside the box, you have the bulb. So the light come in. This light coming to the glass is called incident ray. Incident ray. And this is a normal line. normal to the glass 90 degree. This is called angle incident I. When you measure the angle between the normal and the incident ray, so it's angle incident. Okay, and then when the light go into the glass, tensor already, right? It bend towards the normal. This is a normal bend towards the normal. Then this is the angle refraction, angle R. Okay, so the question here is to see the relation between the angle incident I and the angle refraction R. Understand? Okay, so first step like this lah. You put the glass here on a piece of white paper, then draw a normal line, and then use a ray box, adjust this angle. Okay, let's start this angle with 10 degree lah. Example, 10 degree. Okay, 10 degree. So you measure exactly here 10 degree. So you allow the light go through the glass, let it bend. You mark here, then draw a line, measure this angle refraction R. And next round, you push this ray box down a little bit to make this angle incident bigger. Now maybe 20 degree. Just now was 10 degree. Now you make it bigger, 20 degree. When this angle getting bigger, right? You see the light go here. It will also bend, right? Then you notice that this angle R now become bigger, When this angle I getting bigger, the angle refraction also slightly become bigger. So you can see the relation already, When this angle I small, this angle refraction also small. When this angle incident bigger, you notice that this angle refraction also becomes slightly bigger. So the relationship is when I getting bigger, R also getting bigger. Understand? So you repeat the experiment many, many times now. 10 degree, 20 degree, then make it 30 degree, 40, and so on. And now you see the result. Like that, Okay, copy down in the table. Okay, so first you start with 10 degree incident angle. Then you measure the reflected angle 8. Then make the angle bigger. Then this are also getting bigger. 30, this are also bigger. So you notice here now, when this angle I getting bigger, then the angle of refraction are also same, also become bigger. Right not? So it's directly proportional lah. Same direction ma. This one getting bigger, this one also getting bigger, so directly proportional graph lah. Okay, copy down the value. You don't understand? You don't.
Understand, sir.
Okay, Juling understand or not?
Understand, sir.
Okay, thank you. Good now. Then the rest Zhichen understand? Zhichen Ram understand? Sima understand?
Yes, sir.
Okay, The rest who are? Ram say yes, sir. Understand. Zhichen understood. Okay, thank you. Okay, so this one settled. Done already. Hashini, thank you. Okay. Now we have to go through very fast through the experiment. Okay. Okay, come. Hypothesis. Highlight. Angle refraction increases when the angle incident increases. You know already. Aim. Investigate the relationship between angle incident, angle refraction. Okay. Manipulated variable, you control the angle incident, manipulate the angle I. Responding is the angle refraction R. And fixed variable means refractive index. I want you to tell me what is meant by refractive index. I say fixed variable is refractive index. What the meaning there is what? Fixed variable refractive index means what? Or what is that? You know or not? Justin, do you know or not? You say fixed variable is refractive index. So what is that now, Justin? Any idea or not? Justin? Now, mind, listen now, listen now. Okay. Refractive index means the ability to refract the light. Ability to refract light. Ability to bend the light. No? In other words, mean is the ability of light bending. The ability to bend the light. That is the meaning of refractive index. Okay. How to fix a refractive index, right? Okay. Simple. Don't change the glass. This piece of glass. When the glass you are using for the whole experiment are same piece of glass, right? So the ability of light bending same lah. It won't affect, right? Unless you can change the glass. Because different material, we have different refractive index one, the ability of light bending material and material different one. When you don't change this piece of glass, so basically you already fixed the refractive index. Understand? Yeah. I think you should understand now. Glass block, red box, white paper, protractor to measure the angle, and power supply. This are all known, Okay. The procedure, I think you read yourself. I don't want to explain already. So you know, just now. Repeat the experiment a few times with different angle. Okay. So the experiment done. So it's like that. So we have finished refraction of water. The most is water. Then now just finish refractions of light a little bit only. Okay. Then Hashini, okay or not? Hashini.
Okay, sir.
Yes, good. Turkesh. What's the name already? Turka Devi. Okay, Turka Devi, understand? No sound already, but I think she typed here. See what she say. She say yes. Okay, maybe cannot talk now. It's okay. Thank you. All right, now last one we need to go is sound, refraction of sound. Sound also can bend one, Sound can bend. Okay, of course, sound can bend. You listen. Okay, when you are talking here, right, talking near a wall, then your friend on the other side, you cannot see your friend, but how come your friend can hear what you say? It's because the sound, your voice, right, the sound can corner, can change direction. So this is one clear example of reflection of sound. Sound can change direction, but only when the sound can change direction, so your friend cannot see you but can hear you. Correct? Not it change direction. Okay. So clear example is reflection of sound. Sound change direction. Correct? No? Okay. When the sound will reflect, when the sound will change direction, this is a good question I see here. Reflection of sound occur when the sound passes through layers of air at different densities or different temperature. Highlight this, very important. The sound will bend when the sound travels through medium with different densities or different temperature. Okay, from hot go to cold, or from cold go to hot. Okay. Yeah. Sound can be refracted by balloon filled with carbon dioxide. Okay, this time I need to explain slowly. You all listen. Look at here. Don't look at this one, but look at here. This is a stopwatch. So the stopwatch is clicking, click, 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 click of sound. So your ear is here. So basically nothing here, here nothing. So when the stopwatch is clicking, so the sound travel go into your ear so you can hear lah. There was nothing special, right? So you can hear the sound. Okay, so it's normal lor, because the sound can travel through the air, go into your ear, so you can listen. Correct or not? So what happened now is in between here, suddenly I put a balloon like this, a balloon filled with carbon dioxide. Okay, carbon dioxide gas. Then the stopwatch is here, your ear is here now. So in between here, you put a bit, one balloon. This balloon very special one, filled with carbon dioxide. Okay, now you notice that once you put the balloon here the sound become very, very loud. Suddenly become very loud. Just now here, the sound very soft. But suddenly you put a balloon here the sound become very loud. So it must be a reason. The reason must come from the balloon. What happened to the balloon? Why the balloon will make the sound here become louder? The reason is, of course, is refraction, change direction. So from this diagram, roughly you see already actually this balloon is focus the sound to one point only. The sound will change direction because refraction different density, so it will refract. Okay, let me tell you carbon dioxide gas is denser gas compared to the normal air here. So meaning that when the sound travel through the denser gas, right? So refraction happen. So this refraction will cause the sound to focus at one point. So all the sound energy focus here. So it become very loud, right? So remember this one is because of refraction. Because sound travel from less than to denser. Carbon dioxide is denser. Okay, something like this. When you put carbon dioxide, right, it will focus the sound. But when you change this balloon filled with hydrogen gas, what happens? If hydrogen gas, hydrogen gas is less than compared to the air. Carbon dioxide is denser. Then when you put hydrogen gas, it becomes less than. Less than means the sound no more focus, then the sound will go diverse to different direction. So we go here. When you put hydrogen here, so the sound spread out. So here you don't hear anymore. When you put hydrogen here, the sound not focused, it's spread out. So that you make your sound here cannot hear. Understand that? So the gas is very important okay? Less than denser different okay Okay. All right, now this diagram doesn't show exactly how this reflection of sound happen, Okay, I want you to look at this diagram. It's very complicated, but don't scared slowly. This diagram, let me explain to you first. Okay, the stopwatch is here. So the sound travel less than, A is less than, so it travel. Then from here, this is a balloon filled with carbon dioxide, denser gas. Then you draw a normal here, normal. 90 degrees to the balloon is normal, okay? Then you notice from less than to denser, it must bend towards the normal, so it bend down. Normal is here, bend towards normal. Less than to denser, bend towards normal. Then when you go out, from denser to less than, you learn already. Denser to less than, it will bend away from the normal. This is a normal. Normal means 90 degrees to the surface of the balloon. Away means it also need to bend down, away from the normal. The normal is here, away from normal means come down. So focus to the ears. Understand? So I repeat again. Less than to denser, bend towards the normal. Towards means it's also bend down because the normal is here. Then for denser, go up to less than, is bend away from the normal. Away from normal is also down because normal is here. So bend away from the normal. Okay, so you focus here. Okay, another one is here. 90 degrees, this normal line is here. So from less than tensor bend towards normal. So it bend up. Normal is here towards normal. Okay. So when it go out, tensor to less than and normal now is here, no? 90 degree to the surface of balloon now. Away from normal. When away means it go up also. So it make the sound focus at here. That's why the sound become louder. Okay, understand now? When stopwatch is start, the listener can detect a point only beyond the balloon when the sound is become strongest here. The reason is balloon of carbon dioxide, which is denser, act like a convex lens focusing the sound. This one is not the explanation, but explanation should be like this, Less than to tensor, bend towards the normal, tensor to less than, bend away from the normal. So it will cause the sound to focus here. Okay, take down the diagram, please. Okay. Copy the diagram so that you can understand how to draw the line, how the line bend, okay? Okay, finish a lot, finish the diagram. Okay, finish. So that was refraction of sound wave. One clear example. Okay, we have another example. Okay, we go to the next one now. Okay, class. The next example, you see the diagram on your paper first, okay? This one, this diagram. Okay, this is another example to show the sound get reflected. Okay, so during night time, you don't sing. When you sing, your neighbor can easily hear your singing one nighttime. If you want to sing and then you don't want to let your friend hear, right? So you sing during daytime. Nighttime, you don't sing. Because nighttime, the sound travel go up to the sky and then it come back then down to the earth. So everything, every sound here, it go up, then it come back. So your neighbor can hear your voice during nighttime, but not daytime. Daytime, the sound will go up to the sky. So daytime, okay. The reason, later on you see when during nighttime, right? Nighttime, the lens is getting cooler. Why? You learn in chapter 4, right? The specific heat capacity of lens is very small. Small means the lens can cool down faster. Daytime can heat up very fast. Nighttime it cool down very fast. So the lens basically at night cooler compared to the warm air up here. Okay. So what happens is when the sound, when you sing a song at night, sound actually travel from cold to hot. Cold is denser. Cold air, the molecule come closer, so it's denser. Warm air, hot, so it spread further, so it's less dense. So move from cool air denser to less than warm air, right? So the sound get reflect back. It will change direction, no? Okay, it will change direction. Okay, so you can notice here now. In the warm air, right? Less than medium, actually it go faster. Now you see the lambda getting bigger. Bigger means the sound go faster, you know. So change in the speed happen. When change in the speed, it will start to bend, the change direction. So this will cause the sound to bend down at night. Okay. This diagram doesn't explain properly. Later on, I show you another diagram. We go through this one first. Okay. Yeah. Eastern sound often appear louder and clearer at night. At night, the air near the ground, the air here, often cooler than the air higher up. So here is cool air, higher up here, warm air. You know the reason, land can cool down faster compared to the air, okay? Because it is close to the cold ground. Okay, here cold, okay, Then the sound travel faster through the warmer, less than layer of air. Sound travel faster up here. Warm air, less than, so sound travel faster. And this reflect the sound back towards the ground. It will reflect the sound back towards the ground. This way your neighbor can hear what you sing. Okay. So another example, this one, okay. Now this one, the reason is here. Now I show you why the sound will go up, then it come down. Okay. Okay. Now look at this diagram. It's a little bit complex here, You take a little bit time. I take a little bit time to explain to you this diagram, So this is a ground, the land, cool, so it's denser. Then the air, I divide into one layer, 2, 3, 4 different layers. Okay. Different layers means here is cold, here is also cold, then getting warmer, and very hot, right? So when you sing a song at night, so the sound actually travel from denser to less dense. Here is cold, here slightly warmer. So here is denser, here less dense. From denser to less dense, it will bend. This is a normal line. Bend away from the normal. Besides, it will bend down. Away from the normal, must come down. Okay? And so here to here also the same. Here is cooler compared to here. So this is denser, cooler means denser. Once again, denser to less dense. So once again, it bend away from the normal. So further bend down. So you can see here, bend down, bend down. Okay, but when reach here now, because this angle is so big already, when this angle is big enough, the sound will never go out to the next level anymore. It will be reflect. This one is reflection, total internal reflection. It will reflected internally, totally internally reflected. Okay, within here, it will come back. So if you this angle big, later on you will study this next lesson, total internal reflection. Okay. So this angle big already, so the sound get reflected internally. Then it will come down to the ground. It come down is because of total internal reflection. This is reflection. This one is like a piece of mirror, it reflects the sound. Okay. Okay, please take down the diagram. Okay, copy the diagram for your explanation. You must understand. Anyone has any question to ask or not regarding the diagram? Justin, you got anything to ask?
No, sir.
No. Ashini, anything to ask?
No, sir.
No. Okay, Juling,
No, sir.
no, sir. You Tong, anything you want to ask or not?
No, sir.
No. All no, sir. No, sir. No, sir. No, sir. Yeah, too shy like you all. Susin, you got anything to ask or not?
No, sir.
Also, no, sir. You also learn from them already now. No, sir. Okay, come. So we are finished. And now is the time to answer the question one by one. Okay, you have to go through all the question one by one. Okay, question number one. Which diagram is correctly? Which figure show water wave traveling on surface of water in the river tank? Which diagram is correct? Which diagram is correct then? Lao Yixin, which diagram is correct? Lao Yixin. Okay, let's see your answer. You say boy, the second answer. Let's check. Yes, correct, boy. Your answer is correct, Lao. So here, this one shallow, you see the lambda becomes smaller. Here, lambda big. You must understand. Water shallow. So the wavelength getting smaller. So this one correct. Okay, number two. Which one is the answer? When water passes from deep water into shallow water, how do the speed, the wavelength, the frequency change? They ask you. When water moves from deep to shallow, what happened to the speed? What happened to the wavelength? What happened to the frequency? Very good question. This question you must know the answer. So what happened? Ram, what about you? Ram, can you try the answer? Okay, Ram say no answer yet. But Susin answer already. Susin say donkey. Yes, Susin, you are right. Okay, very good. The answer is donkey. Okay, from deep to shallow, right? Speed decreases, wavelength decreases, but the frequency never change. Okay, so answer donkey. Huh? Okay, number 3. Okay, this one settle lah. Everyone understand lah. Okay, now question number 3. This one another SPM question. This question is very good question. So, what is the answer? Figure shows a water wave in the river tank with a slopey base. You see, the base are slopey one. So here shallow log. Here water getting deeper, correct not? Then the vibrator is here. So vibrator vibrates to produce a water wave lah. So water wave start from here like that. So which are the following physical quantity increases? So which one will get increased? When you move from here to here, from shallow to deep, so which one will increase? Actually, I give you a diagram. This diagram, I think I want you to copy down. Sorry. This diagram, please take it down. Actually, the water wave moving like that one. Shallow go to deep, so you can see here lambda small. The lambda getting bigger, bigger, bigger. Go to deep water, it get bigger, lor. So which one is increasing? Ram say A. Yes, correct. Ram, you're correct. The speed increasing. Okay, thank you. Getting faster lah. When it move from shallow to deep, it go faster, so the speed increases. Okay, here slow, then getting faster. Okay. Take down the diagram, the lambda also getting bigger, Actually, quantity increases actually got two answers. One is the speed, another one is the lambda, the wavelength. The wavelength also getting bigger, right? Also increasing, but certainly here no wavelength. So another answer, please jot down. The wavelength also increases. Lambda getting bigger. Yeah. Okay, next question. Number 4. Figure shows a plain waterway pass from deep water to shallow. Here is deep water. Then go here, become shallow. They ask you which is true. Which answer is true? Which one is true? From deep to shallow. So which one is true then? Okay, who answered? Susin again. She said B. Yes, correct. Susin, you are absolutely correct. So the answer B. The frequency. Actually, the question very stupid. I say the question is stupid because so many things. Then frequency unchanged is correct lah. Because we already know the frequency will never change one, isn't it? Unless you change the speed of the motor, right? Okay, so the answer B is correct. Okay, the rest all wrong one, Only frequency unchanged is correct. Okay, number 5. The diagram is like that. Then you tell me the answer. Figure show water travel from P to Q. Okay, from P to Q. From here, deep already. This is shallow. Why then? Why here is deep? Why here shallow then? Why?
The wavelength.
Justin, again,
The wavelength.
why here is deep, here is shallow?
The deep region, the wavelength of the deep region is bigger than the.
Yes, correct. Justin, you are right. Here you see the wavelength bigger mean must be deep lor. Here the wavelength smaller must be shallow, right? So which one is the answer? Someone answer already. Yes, Susan, correct lah. Answer B also Susan lah. Okay. Okay lah, let's see She say answer B, you know. Is it correct? Yes, correct. Again, correct. It's P lah. The depth of water in P greater than Q. So P is deeper lah. Q is shallower lah, water. Okay, Next question. This one I don't want to explain already. I want you all to try. Figure shows a plane wave made in a river tank with a slopy base. To make depth water X and Y different. X and Y different, you know, you see, Here shallow, then here become deep. It is different, you know. On top here, the water shallow. Bottom here, the water is deep. So this diagram show the patterns of when reach P, when the water move here, which pattern is correct? Up here shallow, no? Here getting deep. So which diagram is correct? Okay, 1 minute from now, you think, So got an idea already? Sima, Sima very quiet already. Now I call you Sima. Sima, any idea?
D, sir.
D, No, not D. The answer is B, you know. Why the answer is B there? Okay, let me explain. Here's shallow. Shallow means the water moves slow. Slow lambda small, correct not? Here is deep. It moves faster and also the lambda big. So meaning that here lambda is big. Here lambda is small. So it will bend because lambda small slow, right? Shallow, lambda small. Small means then here deep, so it move faster, the lambda bigger, so it will bend like that lah. Okay, so it bend become a straight line like that. Okay, then why C cannot be accepted? Why we take B instead of C? Why we choose a straight line? Why we cannot choose the curve? This one is also bend, it bend like that. It's a curve. Why this one cannot? Why we choose this one? Any idea why? The answer is already here. Okay, because this is a piece of glass. Basically, the base is a piece of glass. You put water. Usually, the depth increases uniformly. Here shallow, getting deeper, deeper, and deeper. So it increases uniformly. So when depth increases uniformly, it will form a straight line. Okay, bend in the form of straight line. This one it will bend in the form of curve when the depth from here to here increases not uniformly. Not uniformly. When not uniformly, so it becomes a curve. When the depth increases uniformly, it becomes a straight line. Anything that uniformly, it must be a straight line. Okay? Understand? You don't understand? You don't?
Understand, sir.
Understand? Okay. Good. And other this one no sound one, so many of them no sound one. Chong Chao Yi, understand? Chao Yi, do you understand? Chua Wen, understand or not? They all no sound one. Darren To, understand? Darren. Someone reply. Chua Wen say yes. Okay, Chua Wen okay. Chao Yi also say okay. Understand? Okay. Except this Darren To no response. Darren, are you still there? No? Now the Darren reply. Yes, he say understand, sir. Okay, thank you, Darren. I know lah, some of you got problem, your internet problem, maybe you don't have a laptop, maybe your handphone not good enough. I understand your problem. But you try your best, Lord. Try your best when I say the class online, you try your best to follow lah. Okay. So under this kind of condition, it's like that, more because the tuition center basically still cannot open, Okay. They say can open, but the date they haven't announced when can open. Okay. I also worry, if you want to open, if anything happen, but hopefully let the school open first. After the school open about few weeks, we can see. If nothing happen, then the tuition center also can open. Okay. Let school open first. Because school also basically all the students gather together, right? If nothing happen in a few weeks' time, after 2 weeks, we know already. Your school open from 1 to Form 4 open 15, right? By end of this month, 2 weeks already, you should know already lah. After 14 days, see got anything happen or not. If the number of cases it doesn't shoot out too high, means school we open, no issue lah. So if no issue, then the tuition center can open, no? Okay. But it seems like now the number of cases getting higher and higher, But I see it's nothing to do with the school one. Okay, it's all these adult person outside. Okay, they never wear masks, they simply walk here and there. Okay, your parents also, your brother, sister, you also advise them when they go out, advise them to wear a mask. Better take precaution. No, your father, mother go work, go outside work, go market or what. Tell them to wear a mask Okay, it's important, Like most probably you only go to school, then go home, go school, go home, right? You wouldn't go so many places one. But not your parents. Your parents, maybe your elder brother, sister, they all will go a lot of places. Then you don't know what happened. And then when they come back, so remind them just inform them take precaution It's important, The Prime Minister already announced, it means the country will start to worry already. We want to make wearing a mask compulsory. The Prime Minister said he knows already, he knows the problem already. Okay, he said more and more people not wearing masks. More and more people never follow social distancing SOP. They don't follow already. I think you're in school also the same one. When you see your friend and you forget everything. Sit very close, hugging your friend, holding your friend hands, right? Correct not? Susin?
No lah, sir.
In school, you all never sit close to your friends. I think got
Turn the chair lor, turn the chair.
I see turn the chair lor, turn the chair mean very close already we have to still be very careful, It's not over yet, no. Yeah, this thing not over yet, no. Okay, come, we move on to number 7. This diagram. Figure shows a stone thrown by a boy in a pond. So see that. Here's shallow, here deeper. So this boy throw a stone. The stone dropped at this deeper region. So once a student drop at here, you have water wave, right? Okay, the water wave maybe here circle, water wave like that. Now it come out, right? But my drawing is not correct one. You must know, here is deep, no? Here is shallow. So can you tell me which diagram is correct? Now they ask you to choose. Which diagram show the correct patterns of the water wave? Start from the deep region because the stone drop at here, deep. Then here, shallow. So how? Zhi Zhen, are you there? Zhi Zhen? No response. Then these are who are? Zhao Yi, Zhong Zhao Yi, are you there? Zhong Zhao Yi, can you try to answer which answer is correct? Zhong Zhao Yi. Zhao Yi. Jin Yi Hong. Jin Yi Hong, are you there? Okay, someone answer. Zhong Zhao Yi say answer B. Okay, let's check. Zhong Zhao Yi, your answer is B, The answer not B, The answer is not B. Here is deep, here shallow. When go to shallow, the lambda should be big or should be small one. You think carefully. Shallow, so the water wave move from deep to shallow. When move from deep to shallow, the lambda should be getting bigger or getting smaller. Xiao Yi, you want to try again or not? Try to give one more answer, Xiao Yi. Okay, come. Su Xin answer already. Yes, Su Xin, you are right again. The answer C. Okay. Correct lah, the answer C lah, Here shallow shallow the lambda must be small, correct not? Here deep the lambda big. So the best answer is C lah. Okay. Understand everybody Here lambda small because here is shallow. Over here, deep water, so the lambda is big. Okay? Can I understand? Juling, understand or not? Juling?
Yes, sir.
Can Okay lah. Number 8. See the diagram, you know already lah. This is what phenomenon? What phenomenon is that? Hashini. Hashini?
Refraction.
Yes, refraction. Okay, This one you know refraction because this lesson is refraction, correct? No? Okay, number 9. This one very difficult question. Okay. This diagram show a set straight water ripple in a ripple tank travel over a thick triangular perspective, meaning that moving from deep to shallow, but this shallow shape is triangle shape one. From deep move to shallow. Which diagram shows the wave pattern correctly? Definitely not A, not B already. Between C and D, you choose one. 50-50. You have 50% got it correct. Tips tip is like this, you remember water moves slower when go into shallow region. It moves slower. When you move slower means it will stay behind. The one move faster one will go forward. Okay, someone answer already. Justin. Justin say answer donkey. The rest agree or not? Yes, Justin, you are right. Very good, Justin? It's donkey. Justin, can you explain why the shape is like that? Why not? Why like that, Justin? Can you justify your answer, Justin?
From deep to shallow,
Huh?
the speed in the deeper region will be slower.
Deeper region, you go faster. The shallow region,
will be slower.
Slower. Slower one, it will stay behind, correct not? This one forward, this one move faster, it go in front. This one go in front, this one still stay behind, left behind. Okay, this one go forward, so left, this one left behind. You see, this part left behind, this one left behind, all left behind because it moves slower. It left behind. This one deep one go forward, go forward, go forward faster. This one go faster, faster, faster. Only this part left behind. Okay, so the answer donkey. Okay, understand? Okay, shallow move slower. The deep region, it go faster. So the correct one is donkey. Okay, take down the diagram. Okay. Okay, all right, next question. Number 10. This one is a little bit calculation. Figure show water pass from deep water to shallow. Here is deep, here shallow, right? Okay, now the question. The distance PQ 5 cm. 5 cm here got 2 lambda. 1, 2. So 1 lambda is 2.5. This one you know already. PQ here got 2 lambda. So lambda is 2.5. 1 lambda. Okay. RS is 3. Here. 3. RS is also 2 lambda. Okay. And the speed of the water in deep water, here speed is 4 meters per second, 4 cm per second, the speed here. So now the boundary is here. Now the question, which of the following is true? The answer B, you know. Okay, you all understand it. Why the answer B? Okay, you see, I did some calculation here already, you know. Here lambda 2.5. You know lambda, you know the speed, you can calculate the frequency using V equal to F lambda. Speed is 4, lambda 2.5, so you can find the frequency. So you get frequency here is 4 over 2.5, so times 2 become 5, this one times 2 become 8 log. So frequency 8 over 5. You all must know, you know, frequency in the deep water and in the shallow water, the frequency same one. They will change one, you know. When you calculate here, the frequency is 8 over 5. The frequency here also the same. So the answer B lah. Okay. Lambda 5 over 3 is wrong, but it should be 5 over 2, right? 2.5. So this one wrong. No? Speed also wrong. It's not 8 over 3. You can calculate the speed. You can calculate the speed here one. Lambda 1.5. Frequency. So V equal to F lambda, can find the V lah. The answer not 8 over 3. Okay. So the answer one correct is B. Okay. Then understand everyone? Hashini, understand?
Yes, sir.
Yes, good. Okay. Okay, one last question. 11. Know the answer already lah. When water wave propagated from sea to the beach, the water wave follow the shape of the beach. This one is because of refraction. Remember that, huh? Okay, one more question now. All right, 12. A ray of light passes from water to A. Which label arrow show the directions correctly? Okay, you all find the answer. From water to A, remember no, from denser water go to less than A. So which diagram is correct? The arrow, which arrow is correct? One minute from now, okay, you all look at the diagram, see which one is the answer. Light passes from water to A. Which label arrow show the direction of ray in the A? Denser to less dense, huh? Yes. Okay. Someone answer already. Juling, Juling say donkey, huh? Okay, let's see the answer now. Juling. Yes, you are right, Juling. Donkey. Okay. Because from denser go to less dense is supposed to be go away from the normal. This is the normal line. From denser go to less dense supposed to be bend away from the normal. Okay, away from normal means must go down lah. Away from normal ma, right? So it's donkey. Okay. This one memorize, you know, huh? From denser to less dense, I bend away from the normal. You have to memorize and put inside here. I can't help you, no. If you don't want to memorize, huh? No one can help you. The God also cannot help you. Huh? Yeah. So I think I stop here lah, huh, for tonight. Okay. Okay, this one finish, huh? Okay. All right, now come back here. Anyone got any question to ask or not? Kong Fan Sin, anything to ask? And then all these user one, I don't know who are they. And you never show your name, huh? Okay. Sima, anything to ask?
No, sir.
No, sir. You Tong, any question or not?
No, sir.
No, sir. Okay. Justin, anything to ask? Justin?
No, sir.
No, huh? Okay, if no, say I want to say thank you to you all. Follow the lesson patiently, start from the beginning until now. Okay, so thank you very much. And please take good care of yourself. Work hard, okay? Study well and work hard, okay? Rest well also, huh? Okay, so I see you again next week. Okay, bye-bye. Bye-bye, everyone.
Thank you so much,
Thank
sir.
you,
Yes,
sir.
okay. Bye-bye, bye-bye. Okay, bye-bye.
Thank you, sir.
Yes, bye-bye. Okay, bye-bye. Okay, bye-bye.